Now you will learn about tree sets. A tree set is a set like the hash set, except the elements are sorted in their natural order, and tree set's also a generic class. And in order to use tree set, we must of course import it just like hash set, and we can just import java.util.star or import java.util.treeset if you prefer. Although java.util.star is used to import every single thing in the java.util package, so you will be able to use other things like hash set and array list. And the following are some methods in TreeSet. So first, we have the four methods from HashSet: the size method, which returns the number of elements; the add method, which adds an object to the TreeSet; a contains method, which checks whether an object of a given value is inside the TreeSet; and the remove method, which removes an object from the set. And there's some other methods that are also used, although they're used a bit less commonly. Let's give an example. So let's just construct a tree set. It's similar to constructing a hash set. And the methods work the same way as well. So set1.add -3, set1.add 5, set1.add 7, set1.add 1. And now when I print the set, it should print -3, 1, 5, and 7, which is the set with the integers in their natural order, from least to greatest. And let's do the same thing for strings. So tree set of strings. And now let's print the set. And as you see here, we have capital XYZ first because capital letters come before lowercase letters in Java. And then we have the thing in its natural alphabetical order with the duplicate XYZ removed. Other than the ordering, tree sets work exactly the same as hash sets. Let's try some of the other tree set methods on this set. So first, set2.contains XYZ and set2.contains XYZ except lowercase should return false and true respectively, as shown below. Set2.size should return 5, as shown below. And then when we do set2.remove ABCD, then print set2, then it should print 4 elements, basically the set2 with ABCD removed. Now let's try some other less commonly used methods on this set. So first of all, set2.first which will print XYZ in this case because first returns the least element in the list. And then set2.last which returns the greatest element in the list, which is lowercase xyz. Then afterward, set2.higher, so let's just say CDE. This will give QWE because in the set QWE is the least element that's greater than CDE. If we do set2.higher ABC, it'll still be QWE because ABC is not strictly greater than ABC. And then next, set2.lower ABC would print capital XYZ. And then finally, the ceiling and the floor functions. So set2.ceiling CDE, which will also print QWE. And the difference between this one and higher is that when I do set2.ceiling, say ABC, then it'll be ABC, as shown below. And floor works similarly, so set2.floor of ABC would be ABC, as shown below. Consider the following class point with two instance variables, x and y, and the constructor which sets those variables. Now let's try to create a tree set of point. So tree set of point, let's call that set point set, equals new tree set of point. And let's just add a point to the tree set. Like that. And now let's run the program. If we see that we get an exception, class cast exception, and the reason is because we never defined what ordering point should have. TreeSet should order the elements, but we never specified how point should be ordered. So, in order to fix this, we must make point implement something called comparable, which is an interface that contains the compare_to method. And make sure it implements comparable of point. Use comparable as a generic class, and that way when we do public int compare_to, we can put point as a parameter. And the rules of the compare_to method are the following. If this point is equal in value, then return 0. And by the way, this means that TreeSet will treat this as a duplicate. Treat one of them as a duplicate. So make sure they're actually equal in value if you return 0. Then if this point should come before the parameter or less than the parameter, then return a negative value, which a common one would be -1, for example. And if this point should come after the parameter, so let's just say greater than the parameter, then return a positive value. And for example, commonly used would be 1. So for example, if we want to sort the points by first x coordinate, then y coordinate, then we could do something like the following. If, say, x is less than b dot x, return -1. Otherwise, if x is greater than b dot x, then return 1. And if both of these are not true, if we still go on to the next line, then that means that x is equal to b dot x, which means they're equal in x coordinate. So now let's compare the y coordinates. So if y is less than b dot y, return -1. If y is greater than b dot y, then return 1. And otherwise, that means that both the x coordinate and y coordinate are equal, so then I return 0. And now there's no longer a runtime error. So if I add a few points to this, so point set.add new point 7.9 comma 5.7, and just say 3.5 5.7, 1.2 3.4, and a duplicate element like 7.9 5.7. Then let's print point set. Now, currently we won't get any useful information because we didn't give a toString method to point, so let's just do that first. So return the ordered pair x, comma, y. And now when we run the following code, it should print the points in their natural order, with the 7.9 and 5.7 point treated as a duplicate and therefore only one of them is added. So therefore this tree set has 4 elements. Remember that comparable is a generic interface, and that a class that implements comparable has instances of elements which can be sorted. Just for purposes of illustration, let's just implement what comparable would be like. So like it would look like interface comparable and then e or something like that, and then just int compare to e other. It would look something like that. Remember that all methods in an interface are abstract methods and public. And because we already have comparable inside Java, let's just make this comparable 1. And this would be what comparable looks like in Java. Of course, you don't have to write comparable by yourself each time because comparable is already inside Java. Suppose now we want a tree set of integer, except the integers are sorted in descending order. How would we do that? Well, first of all, integer already has its own compare to method, so we can't rewrite that. And if integer didn't have a compare to method, by the way, we wouldn't be able to create tree sets of them because integer is already defined. We can't just add on a method into it. So integer already has a compare to method, which means that if we just directly do tree set of integer, like that, and then I just do int set dot add 3 int set dot add 7 int set dot add 1 int set dot add 5. When I print it, it would be 1357. If I wanted it to be 7531, I would have to use something called a comparator. So in order to do that, I need to create a new class. Let's call it descending order, that implements a generic interface called comparator. So implements comparator of integer. Then inside the descending order class, I would need a compare method. So public int compare, because that's the method inside comparator. So it takes in 2 parameters, and since this is a comparator of integer, the parameters are of type integer. So integer a and integer b. And the rules are this: if a comes before b, then return a negative value. So say -1. If b comes before a, then return a positive value. And if a is the same value as b, then return 0. So for example, if A comes before B, so that's, since we want descending order, that's if A is greater than B, then return -1. If A is less than B, then A should come after B in descending order, so then return 1. Then otherwise they're equal, so return 0. Then afterward, all we need to do is pass an instance of descending order, so new descending order, into the TreeSet constructor as a parameter. Then now when we run the program, it's 7531. This int set officially sorts the integers in descending order, as shown below. Here's an exercise. Create a tree set of point that sorts the points by y-coordinate, then by x-coordinate. So for this one, there's two ways to do it. One way would be to change the points compare to method. But there's a disadvantage to doing that, and that is that we can only keep one sorting method at a time then, which is not good. And another problem is if point is already like an external class, then we wouldn't be able to change point just for this single problem. So then that's not a good method to do this. So instead, let's use a comparator. So class, say prioritize y, it doesn't matter what you name this class, then implements comparator of point. Then basically public int compare point A, point B. If a dot y is less than b dot y, then a comes before b in this ordering. So then therefore return -1. If a dot y is greater than b dot y, then return 1. Then otherwise their y-coordinates are equal, then we prioritize the x-coordinates if the y-coordinates are equal. So then a dot x is less than b dot x, return -1. Then if a dot x is greater than b dot x, return 1. Then afterward, let's just return 0, because then the x-coordinates and y-coordinates are both equal. So now all we have to do is create a tree set with point. So let's call this points. And all we have to do now is pass an instance of prioritize y. So new prioritize y, and then we're done. So now when we print, we get that the y-coordinates are sorted, then the x-coordinates, if the y-coordinates are equal, as shown below. Just for some additional information, here's another application of comparator. Let's just say we have an array. Let's set it to, say, 5, 9, 7, 1, 3, and we want to sort it. Then we just do arrays.sort arr, right? And then when we print the array, we would just get 13579. As shown below. Now suppose we wanted to sort this array instead in descending order, so 97531. How would I do that? Well, it turns out, unfortunately, we need this array to be of integer. Then afterward, it turns out we can do the following. Arrays dot integer sort arr, and passing our descending order comparator in here. And now when we run the program, it's 97531. Now you don't need to learn what this is. It's something called a generic method, but if you're curious, you can go search it up. Similarly for array lists, if we create an array list of integer and then add 5, add 9, add 7, add 1, add 3. Normal sorting would be collections.sort list. And when we print the list, it would be 13579. However, if we wanted to sort it in descending order, then we would have to do collections dot integer sort list, comma, and then our descending order comparator. And then it would print 97531 for the list, as shown below.